So let us continue with chapter 3.3 about electromagnetism or electromagnetic wave. Okay, magnetic wave. So it's just a short description about it. We start from radio wave, microwave, infrared, visible, ultraviolet, X-ray, and gamma. Okay, so what's the difference between the radio wave, the microwave, infrared, visible until gamma? What's the difference between them? So we know that the speed of light is c, is a constant, so 10^3 to the power -8 meter per second. Okay, so after that, you know c is actually f lambda. Okay, c is actually f lambda. So radio wave have long wavelength. If radio have long wavelength, microwave shorter, getting shorter and shorter and shorter and shorter. So the wavelength is getting smaller, but the frequency is actually getting bigger. So when you answer the question, you need to think about this, about the wavelength and the frequency. So what does it affect one another? Okay, we learn about travel waves. We have diffraction or visible light dispersion of light. Those kind of things you need to think about is what's the effect of the wavelength and the frequency. So answering question regarding those questions, like for example, why use this wave, why use that wave, you need to think about like this. Okay. So another thing is the application of all these different kind of wave. So we start from radio wave. Usually radio wave is all about communication. So we can say is communication. Communication is about or navigation. Okay, both radio wave and microwave are quite similar. Usually, radio wave is terrestrial navigation, means that it's outer space, and microwave is inner space, which is like for example Wi-Fi, for example mobile phone network. Those are the inner space of communication. So that's the main difference between them. To be honest, for me, I don't think there's a much difference between one another lah. I think they says that the difference between them are if I'm not, it's 3 gigahertz. I think that's the written not gigahertz, sorry, gigameter, something like that lah. I don't forget already. Gigahertz, gigameter. Okay, I just forget. Okay, there's a major difference between them and that lah. Okay, so infrared is just thermal, so usually thermal, so we can say remote control, thermal imaging, very simple. Okay, just talk about the very simple thing. Visible, okay, is like vision. Okay, you can see something. Ultraviolet, we can say is about sterilization. X-ray, okay, very medical equipment. And gamma ray is about cancer treatment. Okay, so that's the application for all of it. Okay, usually this one. Okay, for sterilization also can use gamma lah. Okay, sterilization they also use gamma. Okay, so see how you answer it. Okay, another thing is analog and digital. Okay, another thing is analog and digital. So what's between the difference between analog and digital? Okay, so what's the difference between them? Okay, so for example, when we say analog, which is the signals, we say that the signals is varies continuously in its frequency and amplitude. Okay, means a range vary over a range, and digital is not. Okay, so digital Digital is about consists of either on and off lah, so or you can say consists of two values means 0 and 1 only lah. Okay, so that's the video. So what's the advantages of using digital signal? So digital signal is noise can for digital. Noise can easily remove. Okay, and faster data transmission. Faster data transmission. Okay, so that's the advantage of using digital. Okay, so that's the difference between them. And this all about chapter 3.3, electromagnetism. Okay, electromagnetic wave, all of it. Okay, we'll continue with chapter 3.4. Okay, going on the side, chapter 3.4. So we already talked about transverse wave. For example, is EM wave. Another section we talk about is 3.4 is sound wave. So why we want to specifically talk about sound wave? Because it is a longitudinal wave. So I'm gonna talk about it. So sound wave is quite is very simple. Is just a few information. The first thing is we know that sound waves is between, for the human ear, the sound waves is between 20 hertz to 20 kHz. Okay, the second part is when we measure sound wave, usually V equals to D over T, very simple. And third is the characteristic of sound wave. So what is the characteristic of sound wave? So we split into two parts. The first is so the mainly difference about wave is we can change two or three things. One is amplitude, the other thing is frequency, and the third part is maybe wavelength. Okay, so what happens if we change the frequency? Okay, why we change frequency? So when we change the frequency, it's also change the wavelength lah. So this two part is I can say is actually the same thing lah. So what happened to the frequency or the wavelength? So if you have a low frequency means you have a bigger wavelength. Okay, bigger wavelength means like this. It means that we have a lower pitch. Means deeper voice. Okay, if high frequency means higher voice, high pitch. Okay, so usually men talk with the lowest pitch and female talk with the highest pitch. So that's the written characteristic of sound wave. And the other part is amplitude. So amplitude is this. Okay, amplitude is this, or this one is lower amplitude. Okay, the high amplitude means more energy lah, so it means a loud sound. So high amplitude is a loud sound. Okay, so main difference the main characteristic of sound wave have two, which is frequency and amplitude. Lower frequency, lower pitch, higher frequency, higher pitch, and the amplitude, higher amplitude means louder sound and lower amplitude is louder sound. So that's the characteristic of it. And the last part is the usage. So ultrasound, what is ultrasound? Ultrasound is more than 20 kHz is called an ultrasound. If the frequency is more than 20 kHz, it's called an ultrasound. It used for medical imaging. And you know the difference between the ultrasound and the other one is, what do you call it already? Ultrasound. The ultrasound or X-ray, yeah. Ultrasound is to scan the tissue. You check about the tissue of the human being or tissue of human being. And we say X-ray is about bone. Okay, being. Okay, medical imaging. They use, for example, echo. So medical imaging, they echo, they reflect back and calculate, and could say, oh, there's a medical imaging about human baby inside a woman. Okay, so that's it. So ultrasound, more than 20 kHz. So this is all 3.4, and this 3.3 is all usually talk about what is EM wave and what is sound wave, transverse wave and longitudinal wave. So that's it. Okay, so it is all here is all chapter 3.